The focus on this video will be on the unit circle. So we're going to look at some problems that will involve the unit circle. So let's look at the first example. Find the exact values of sine t, cosine t, tangent t, and of course the reciprocal function values, cosecant t, secant t, cotangent t. If the point P is the point on the unit circle that corresponds to the real number t, where t represents an angle, we can say it's in radians, it could be in degrees. So here's what we need to know, what you need to know. If you have a unit circle and you have a point on the unit circle, and how do we know this point is on the unit circle? Well, you can test it out. The distance from the origin, which again the unit circle has a point center at the origin, 0, 0, and the radius of that circle is 1. So notice if I compute the distance from this point to the origin, this would be the square root of minus radical 11 over 6 squared plus 5 over 6 squared, 11 over 36, as I'm squaring this, and then 25 over 36 gives me 36 over 36, which is 1, and the square root of that is 1, so it is a unit circle. Radius is 1. So what we know is this: if the point is on the unit circle, the sine of the angle in radians or degrees, in this case would be t, the sine of that angle is whatever the component of the second point of the order pair is. So 5 over 6, that's the sine of the angle. And the cosine of that angle t is equal to the first component. So this is x, you can call this x and y, and the radius. And this works because the radius of the circle is 1. So cosine is the first component. So this will be minus the square root of 11. Over 6. And the tangent of angle t, the y coordinate, 5 over 6 divided by the x coordinate, minus radical 11 over 6. So 5 over 6 over minus radical 11 over 6, the 6's will cancel out, and that'll give me a minus 5 over the square root of 11. And then we rationalize this, multiply by the square root of 11, top and the bottom, numerator and denominator. This is going to be minus 5 square root of 11 over 11. And then for the other three, they're just the reciprocals. So the cosecant of t is the same as the value for sine, except it's the reciprocal. So cosecant of t would be 6 over 5. And then the secant is the reciprocal of cosine. So secant of t would be minus radical 11 over 6. So let's write that as, put the negative on top, negative 6 over the square root of 11. Rationalize this, multiply by radical 11, numerator and denominator, so it'll give you minus 6 radical 11. And radical 11 times radical 11 is the square root of 121, which is 11. And for the cotangent of t, it's just a reciprocal of what we got for tangent. I'll use this part of the answer here, that way I don't have to rationalize, so this will equal, I could use this part right here, but then I'd have to rationalize all over again, so here I just invert, this gives me minus radical 11. Over 5. And that's it for this one. Now find the exact value of tangent of 8 pi. But for this one, we're just rotating this. The angle just rotates several times, and eventually it comes back over here. So we can just say, well, the unit circle then at that point would be 1 0. And the tangent is defined by the y over the 1, so this would just be 0 over 1, which is equal to 0. Now for the other ones here, find the exact value, and again we want to use the unit circle. Do you have to? No, you don't. You can get these using reference angles and so forth, but the instructions are to use the unit circle, so you have to have the unit circle, or you can create it. And keep in mind that if the angle that you're looking at doesn't appear in the standard diagram, you can always add multiples of the period. Some functions have a period of pi, the tangent, the cotangent, and the others will have a period of 2 pi. So tangent and cotangent have a period of pi, and the others have a period of 2 pi. So it's 180 or 360. So for this one here, find the exact value of cotangent. So let's look at the unit circle. Here are most of the standard angles here. So you want 13 pi over 4. And we don't see it here. So we can subtract multiples of pi until we get something that falls in one of these sections here. So if I take 13 pi over 4, instead let's subtract the period here is for cotangent is pi. Let's see if we can subtract here. We want it to stay negative here. So this is 1 here. So we make this a 4 here to have a common denominator. So multiply by 4 here and 8 here. 4 times 2 is 8, so 13 minus 8 pi over 4 will give us 5 pi. Over 4. So I can rewrite this. Say this would be the same thing as the cotangent of 5 pi over 4. So then I would just find 5 pi over 4 and the diagram for the unit circle, and the cotangent would be whatever coordinates are given would be the x over the y. Tangent is the y over the x. So this is going to equal 2 so here it is, 5 pi over 4 has these coordinates, minus radical 2 over 2, minus radical 2 over 2. So the cotangent is minus the x value over the y value. So this is minus radical 2 over 2 divided by minus radical 2 over 2. That's equal to 1. So we can write just like I said, cotangent of 5 pi over 4, and that's just equal to 1. Now for this one then, this was in degrees. So let's go ahead and simplify this. We can subtract multiples of 360 here. So this is going to become the same thing as the cosecant, 45. Now again, we can do this without the unit circle, but since they want us to use the unit circle here, we look this up. 45 is pi over 4. And here it is. Then the cosecant is the 1 over the y component. There's just 1 over the square root of 2 over 2. We can write that as 2 over the square root of 2. Rationalize, multiply by radical 2 here, radical 2 here. This is going to be 2 square root of 4, and then this and this will cancel out. This will give me the square root of 2. Now let's look at the sign of 7 pi over 6. You can see it right here. 7 pi over 6 and has components of minus radical 3 over 2. And the y value is minus 1/2. But if you have a unit circle, the y value represents the sine of that angle. So the answer to sine of 7 pi over 6 is negative 1/2. It's negative 1/2. And again, I'll remind you again, if you're just given the option to evaluate these without using a calculator, you can do this by using reference angles, using your 30-60 triangle and so forth. But we're using the unit circle here. Now for the next one, we want the cosine of 330. The cosine of 330. So you can change this, because the unit circle is given in terms of radians here, you can convert this 330 to radians using multiples of pi here for your standard definition. And this turns out to be 330 in radians, the same thing as 11 pi over 6. This is 180 divided by 6 and then multiplied by 11. That'll give you 330. You can easily check it. So we're looking at 11 pi over 6 on the diagram. So here's 11 pi over 6. And we're looking for the cosine of that angle. That's always the first component of the point. That's radical 3 over 2. There we have it. And then for the tangent of 300, again, I can rewrite this in terms of radians. And 300 degrees in terms of radians is 5 pi over 3. Pi over 3, remember pi is 180. So 180 divided by 360 times 5 gives me 300. So 5 pi over 3 is the conversion of 300 to radians. So let's just look that up. And here it is. 5 pi over 3 has coordinates on that point in that circle, 1/2 and minus radical 3 over 2. So the tangent is given by the y coordinate over the x. So if I take minus radical 3 over 2 divided by 1/2, that the 2's will cancel out and leaves me with minus 1/2, minus radical 3 rather. So minus radical 3 over 2 divided by 1/2 gives me minus radical 3. This is equal to minus radical 3. Okay, and the next one, use a calculator. Okay, so now we're just using a calculator to find the value of cotangent at 3.2, cosecant at 515 degrees, and so on. So A is in radians, and C is in radians. B is in degrees. So let's do the ones in radians first. So go to mode. The calculator is set to degrees, so you want to make sure you put it on radians first. So click enter there. So now, calculator has your sine, cosine, tangent. Doesn't have the reciprocals here, but we know that the cotangent and tangent are reciprocals. So we can just say the cotangent of 3.2, that's in radians, is the same thing as 1 over the tangent of 3.2. So to find the cotangent of 3.2, we find the tangent of 3.2 and then take the reciprocal. So I'll just write it this way here. Calculator's in radians, so this will be 1 divided by tangent 3.2. Hit enter. And there you have it. So the answer to that one, 17.102, you can write it out to one place depending on what they tell you. 17.1, that's the value of the cotangent of 3.2 radians. Clear this. Let's go to the next one. Cosine of 5 pi. Okay, so here we just hit cosine, and then it's 5 pi. So here's the second pi, and then it's divided by 7. Calculator set to radians, so no problem. Hit enter, and the answer comes out to a negative 0.6234, so on. You can run it as you please or what they tell you, minus or negative 0.6234, and so on. Clear this. And then B is in degrees. So here I'm going to go to mode, put it 2 degrees. And so here I want the cosecant of 515 degrees, and cosecant and sine are reciprocals. So the cosecant of 515 is the same as 1 over the sine of 515. So I'll just do it over here just to shorten it a little bit. 1 divided by the sine of 515. And again, calculator set to degrees here. So this 515 here is in degrees. Hit enter. So I get 2.36620 and so on. You can round this off accordingly. That's your answer. Now the next one. The point -10 and -2 is on the terminal side of angle theta. Find the exact value of the 6 trigonometric functions. Quadrant 3. So let's say this point right there is a point -10. We go -10 over, and then -2 down. Is on the terminal side of angle theta. Find the exact value of the 6 trig functions. Now this is what is called an angle in standard position. The initial side is along the positive x-axis, and the terminal side is somewhere else in the quadrant. In this case, the second quadrant. This is a special case of the unit circle, which basically tells you that if you have an angle in standard position and you can locate any point on the terminal side, you can find the trig function values of that angle. So it basically tells you this, that the sine, and this is the angle theta, is the x value. I'm going to call it r, where r is the distance that point is from the origin. So basically I want to find the distance from the origin. So this will be the square root of, and using the distance formula, this gives me the square root of 104. 104 is 4 times 26. 4 times 26. And the square root of 4 is 2. And then I leave the square root of 26 under the radical. So the distance that this point is from the origin is 2 times the square root of 26. And here's what we come up with using the unit circle, which hopefully you went over that in class. Tells me then that not the x value but the y value over the radius. You can think of a circle of radius r. Instead of a circle of radius 1, which is a unit circle, we have this. So this is going to be, the y value here is -2, and the r value is 2 times the square root of 2, or the square root of 26. Reduce these, give me -1, the 2's cancel out, -1 over the square root of 26. Multiply numerator and denominator by the square root of 26, I get minus the square root of 26 up here over 26. So that's the sine of the angle. Now the cosine, using this idea, again we're looking at angles in standard position here, which are basically derived from what we learned from the unit circle. The cosine of theta is the x over the r. Again, where x is just the first component of the point that's on that terminal side, and r represents the, you can call it the radius of the circle, or the distance that that point is from the origin. So the first component, x, is negative 10, and r is the same, 2 times the square root of 26. Notice 2 goes into 10, negative 5, replacing with the square root of 26. Multiply by radical 26 to rationalize. So the cosine of the given angle is negative 5 times the square root of 26 over 26. And using this, again, same concept, the tangent of that angle theta in standard position with point on terminal side, negative 10, negative 2, and radius, if you want, or distance from the origin, is 2 radical 26, is given by the y value over the x value. So the y value is negative 2, and the x value is negative 10. Reduce that down to 1/5. Okay, so that's your sine, the cosine, and the tangent. It also wants the reciprocal ones, but again, you already have the answers there, because all you have to do, we could just take the reciprocal of the answer, or to make it easier for the cosecant, we could reciprocate this. So this goes to the top, the negative 2 goes to the bottom, and this reduces to negative the square root of 26. So the cosecant of theta would be the reciprocal of the sine, and this comes out to negative radical 26. And so this is the cosecant. And the secant of theta is just the reciprocal of what we got for the cosine. So from this point, easier to reciprocate here. So the 2 radical 26 goes to the numerator, negative 10 goes to the denominator, and you reduce that. And this comes out to a negative the square root of 26 over 5. And then the cotangent of the angle is just the reciprocal of what you got for the tangent. Cotangent and tangent are reciprocal. So in this case, I take the final answer because it doesn't have any radicals, so it's 1/5. All I got to do is take the reciprocal of that, 5 over 1. Gives me 5. So those are the values of those trig functions, the main functions and the reciprocals. Thanks for watching. We'll see you next time.